Team Scatter is a mixed team with researchers from IMEC in Belgium and researchers from Rutgers University.
I'm Prashanti.
Dragoslav.
And I'm Ivan, and we are the US part of the Scatter team. The division of labor is really focused on three separate areas. One is the actual hardware operation, which is what we are mostly focused on. And that means interaction between various components, hardware components of the software-defined radio, FPGAs, CPUs, and GPUs. The team in Ghent was focused on Mac and PHY-layer CPU-based. And then the team in Antwerp on AI that's sort of governing the whole design.
My name is Carlos. My background is in different wireless technologies such as Wi-Fi and LTE, and also I have some expertise or some experience with software-defined radio application.
My name is Pilios, and I'm actually leading together with Carlos technically the team.
Our approach, you could see it as a scattered approach because we follow a decentralized, a distributed approach.
Nowhere, somewhere in particular, but not absent in any other space. Scattered.
Yeah, I'm Ruben, and my expertise is in optimization problems most of the time by using machine learning and artificial intelligence.
My name is Mikhail. I'm doing research in the physical layer. So the reason that the physical layer is challenging is DARPA is pushing us to the limit. So you have to use the best technology. You have to go all the optimization possible on the physical layer, and that makes it fascinating.
And this, I believe, is the unique feature of the Spectrum Challenge, that it's actually forcing us to put all of this together, not just on the Rutgers side, but also on the Ghent and Antwerp sides, to sort of create a monolithic design that can handle a variety of scenarios that Spectrum Challenge throws at us.
Once you finally make it work, it feels amazing. It feels like a huge accomplishment. But it's a long time before it actually happens.
In Scatter, the main focus of our system is on flexibility, adaptability. We always try in our design to be as generic as possible so that we can not only deal with the scenarios defined by DARPA during the competition, but that we can also deal with unknown scenarios. So I think that is maybe also some unique feature of the Scatter system.
Scatter system, it's not tailored to a specific scenario that's given in the collaboration challenge. Yeah, in that way it is generic, that it just looks at the environment, senses it, and then just adapts to that.
Arguably, the most interesting aspect of it is that we have a huge number of tunable and modifiable parameters that are controlled by the AI layer. And the question is, can we come up with a really adaptable strategy in the AI to sort of manage all the different scenarios?
The key challenge of SE2 is to actually build a system that can use Spectrum, collaborate with other teams, be able to have multiple agents running in the same Spectrum domain, and still be able to handle specific quality of service requirements. I think that's the key, that's the heart of SE2. And that's actually the problem of using Spectrum in 10 years from now all over the globe. We have to change the way we use Spectrum, and SE2 is going to be a major leverage to convince the world that actually we need to change the way we use Spectrum.
The logic of our system is spread on different modules, so each module is responsible of different decisions.
I think that's one of our strengths. We can easily replace certain modules without breaking the entire system. If we want that a certain part of our system react in a different way, we are just able to swap two models, for example, without changing anything else, and everything will hopefully stay working. And I think that's the great advantage we have in our system, that it's really modular and we can plug things in, turn it off. Because we have such a flexible system, we have a lot of knobs, so the number of actions are almost infinite.
So some of them are very basic knobs that you can just control a very specific aspect of an algorithm or of a decision engine, but there are other hyper knobs that can actually have an impact on multiple aspects of the system. And those are, of course, the most important knobs that we're trying to monetize for SE.
we can jump in the spectrum holes that are not used. While today, if you used fixed channel allocation, if there is no channel available, you are done. But with the solutions we develop within Scatter, we don't care if we see any spectrum hole, we can easily jump in without killing other ongoing traffic, because that's also important.
We are scattered spatially, we are scattered in the spectrum, and we're also scattered disciplinarily. So I think we have 3 axes of scatterization in the system.
I think all of the above, right? It describes both strategy and philosophy, as well as the fact that we are scattered around the globe. So, you know, it's all of those together, and it's actually a really appropriate name for our team.
No, it's like this. Is it, which one is on top, the red or the blue? I don't even know. Yeah, it's either this or this. There are no other options. Here we are Team Scatter.
The other way.
You won't see us coming. That's the magic.